Okay, good day ladies and gentlemen. Welcome to my VRed presentation for 3D visualization and virtual prototyping. So firstly, as we scroll down, a little bit of an introduction. Who am I? I'm Quinn Kennedy, I'm application engineer, part-time trying to take over the world, etc, etc. Though, in all seriousness, rendering is one of my things that I'm also passionate about, but mostly I deal with things in the manufacturing industry. And it's just what I love about the visualization side is that it helps bring out some of the fun and interesting parts of it to show your products that you design in a real world scenario, a virtualized part actually in what we could consider real. It's also very good for showing customers, etc., how things will look once it's made. So, just moving along with that, looking at our agenda, as you can see, we've got quite a lot to go through, but I'm going to be hopping through some things very fast, and we've got lots of video clips, things to go in, so it's not hopefully going to be a complete death by PowerPoint presentation. But just a little bit of a note, if you take a look at some of these pictures and all these renderings that I've got in here, these are actually all done in VRed. And if you just take a look at some of them, they're actually pretty astounding. And one of the topics I'm going to cover here is then, why would you rather use VRed over another package, such as something over like 3ds Max? And I'll get to that in a second. Firstly, let's go for the top. What is VRed? So in this bunch of text that I've got on screen here, in a nutshell, it is something like Keyshot or discontinued or showcase that we've had, which allows us to then take whatever models we've got that's already been made, maybe in Inventor, Fusion 360, whatever it is that we've created it in, bring it directly into VRed, either use those actual materials, reflections, anything that we've already built, and reuse that data. So it makes our life a lot easier and faster too. Plus we can then reuse this data, not just in the VRed itself, but we can take it further. We can then add things on and then do even virtual reality systems, simulations, product showcases. We can take this and actually use it as assets in things like Unity. It is a very powerful application. So with that also then, what's new in 2021? There is quite a bit that's new. Lots of little things have been added. I was actually quite astounded when I first took a look at the list. It's quite a lot of stuff in there. So firstly, in the what's new, is the VRed core. So a lot of people go like, oh, okay, VRed core, what's that? Well, I must admit I had the same thing myself, but it basically helps to take what we've got and just improve upon it more. So it allows us to stream our ray tracing in real time, which is quite a significant thing, because this means that we can take what we're doing and show it to somebody else that's maybe not sitting here or at your current office, but elsewhere in the world. And what do I mean by that is, if we actually jump to over here and we take a look at the setting, in here on this backplate you can actually see a vehicle that's being rendered with actually the scene in the background, and the rendering from the background is actually then also being rendered upon the vehicle itself, which is pretty impressive if you take a look at what is being done there. Also, if we take a look here, one of our Autodesk videos that we've got, and if we just take a look at this video, it explains quite a bit about what we're currently looking at and what it does.
To a browser. You just have to enable the web server under Preferences, where you can also select the streaming port. Here I'm opening up my web browser and use the IP address :8888 to enter the web server's web interface. From here, you can access the VRed stream and also the VRed stream app. In the VRed stream, it's also possible to navigate in the scene, use touch sensors, and interact with HTML5 content. The VRed stream app is a web app example that uses the H.264 stream plus an HTML UI to control the scene. Here I can trigger variant sets, viewpoints, and certain VRed quality scene settings. I can also explore the scene on a mobile device when not being in the office and not having access to a high-performance system. Or I'm connecting to a master using a tablet while presenting the VRed scene on a big screen. Also streaming the content back into a VR scene using the media editor is possible, so you can control the VR scene using its own stream. Or you can stream a collaboration session where people are exploring the scene in VR at the same time. This gives you much more freedom in exploring your VRed scenes. Thanks for watching the video.
So basically, as you saw from that, with the streaming capabilities of what it gives you, it's quite powerful. So next on our list is VRed Go, and VRed Go is a godsend for people who share data with others, and it's actually one, in my opinion, is one of the features that actually really makes this 2021 really worthwhile and really worth looking at getting. Because what it does is, if you're familiar with something like Inventor's Pack and Go feature, it literally takes your entire model, puts it all together, and it zips it into a one executable file that you can send over to somebody and they can open it. And this blows open a lot of doors, because they do not need to have bits and pieces of files everywhere. They do not need to have a special viewer. It cuts out the middleman. It makes your life, or makes your client's life especially, also very easy, and that all they have to do is worry about a single file. And just to quickly demonstrate this, I'm just going to play you another video here. None of our lovely Autodesk videos that we've got.
In VRed 2021 we added the option to export a VRed Go executable. Just go to File, Publish VRed Go. Here you can select if you want to use it for VR instantly or in desktop mode. Set the resolution of the render window and set a password with expiring date. The VRed Go executable will contain the current VRed scene plus some parts of the VRed engine. HTML overlays will need to be on the same path, or the complete code has to be inlined into the HTML editor. After the file is created, you can open the VRed Go file on a different system and explore the scene there. This is very helpful, for example, when doing a presentation on a system where no VRed is installed, as the VRed Go file does not need any license. Thanks for watching the video.
Yeah, guys. So what was brought up there at the end is also very interesting, is that you don't need a license to run this VRed Go. So you could give that out to anybody that you would want, and they can view it. Or otherwise, as they said in that video, you could then take it and put it onto a customer system, etc. You don't have to also worry about installing software, as a lot of us know it takes quite a lot of time. Cool. The next section I'm just going to go through is the GPU ray tracing. Now, this has got a bit of a little bit of a issue with it. Well, not really an issue, should I say, is that you have to have an NVIDIA card, I'm afraid. And as I've stated over here in the bottom, the driver version has to be 441.66 or newer. And this is so that you can take advantage of GPUs in NVIDIA's driver technology, or NVIDIA's technology itself. And what this allows us to do is things like speed up our rendering significantly. We are leveraging the power of the GPU itself. GPU being the graphics card. Going to play another one of our lovely videos.
In VRed 2021 we are now able to do ray tracing on the graphic card. On the ray tracing button in the main menu, we added now a drop-down menu where you are able to switch between OpenGL, CPU and GPU ray tracing. You can also use NVIDIA's denoising additionally. denoising quality can be set with the real-time anti-aliasing quality settings. This new feature is supported with Turing, Volta, Pascal and Maxwell cards, while RTX is recommended, and we support 2 graphic cards per 1 VRed Pro license. This new feature gives you the maximum flexibility for your hardware choices. Thanks for watching the video.
Cool, so as you can see there, our GPU ray tracing options gives us a lot more power that we can actually use from our existing systems, because a lot of systems these days are still depending solely on CPU, which has got some of its limitations. Although GPU does also have some limitations, it is still a good option to use. Next section is the Autodesk Drive Smart Reference Support, which basically, in a nutshell, I'm not going to go too deep into this, but it allows us to take our shared folders and use it on any of the Autodesk drives, which means that it goes and it manages any dependencies, references, anything that we've got that links our files together. And then if any updates do occur, it will then publish a notification to everybody's system saying, hey, there's an update, you might want to check this out. So it is a very helpful little feature. Another one is the script editor integration. Although there's been Python script in the backend, they've just enhanced it and they've made some of the features definitely a lot better. Content adaptive shading. So it basically helps with fine-tuning our shading per the material. It is useful in a lot of cases, especially when you get things like your lines and that are slightly off, which causes the Moire effect. I hope I'm saying that correctly. Yes, so basically it's an effect that happens when you've got lines that are very close together, that are maybe not exactly parallel, and you get a strange shading effect over it. So this content adaptive shading can then help to eliminate that by adaptively shading it. Another one that we've got is Subsurface Scattering in VRed design, which has already been in there, and it is actually very helpful. Now, what this thing does, which a lot of people don't realize, is that it takes what we've been having issues with in the past, with having very thin objects that are not exactly translucent, but allows light to penetrate at a slightly different depth, and it basically, it's also with the way that it scatters. If I play this video, it may make a little bit more sense.
In VRed 2021 we have now improved the way we are calculating subsurface scattering. The new algorithm is a brute force volume scattering algorithm. This is very helpful for materials like translucent plastics, marble, skin or leaves. In the material settings of a plastic you can enable the volume scattering and choose between 2 types. Below you will find all necessary settings for achieving different subsurface scattering looks. This new feature gives you the possibility to get a more realistic and physically correct look and behavior of your materials. Thanks for watching the video.
Cool. So with that, you can kind of see that we've got quite a lot of options that's been presented to us. There is actually many more tweaks, improvements, and we'll also talk about some of the other stuff that will be mentioned on a little bit later, like lighting, for instance. That's also been improved, but I haven't really put it down yet, because those were some of the more major ones that I wanted to show off right in the beginning. Okay, so one of the things is, why then would you want to use this software over something like 3ds Max, or maybe one of the other software out there? I mean, why not just use that? And in a simple answer, I mean, you could go directly to Max in that, but VRed just makes things faster, more streamlined, especially if you do not already come from a 3ds Max background or one of the other pieces of software out there, where this is an in-CAD workflow where you can actually use everything together and you can leverage the power of whatever you've taken it from directly in VRed itself. Plus, it's got a lot of features going for it already, as what we'll also be discussing a little bit later on. There is one thing that I did almost forget to mention here, is the collaborative features, which we'll also be touching on a little bit later. Okay, so one of our first things that I'm going to go on here now about is the lighting. So lighting, if you've ever played around with a lot of rendering in that, people, actually, especially newcomers to rendering, don't realize how much of a key feature lighting actually plays. And this is kind of critical. So because it's so critical, VRed actually focuses quite a lot of, it was got quite a lot of interesting things on lighting itself. And as you can see here, I've basically taken and I've gripped and I've pulled little bits and pieces from all sorts of places that I found, and just to give you an examples of what different lighting types you've got. So these are kind of like a base lights, if you want to call it that we've got, which includes our directional lighting, point lights, spotlights, spherical, and then also disc or rectangular if you want those. So those are delta area lights. Then we've also got our more technical lights, though this is in VRed Professional. Just to also add a little bit more about in the lighting area, I got another one of these lovely videos to play you.
In VRed 2020.1 we have implemented the support of area lights from HDR Light Studio. When creating a light within HDR Light Studio and set it as an area light, VRed will automatically create an area light node under the environment group using the same textures like in HDR Light Studio. All values will be taken over from HDR Light Studio instantly, so you can directly see the changes in the VRed scene, like changing the brightness, or moving the light, or changing its size. This gives the user more flexibility and a seamless workflow for creating new environments using HDR Light Studio and VRed. Thanks for watching the video.
So as you saw there, with that HDR Light Studio, it is actually very helpful, especially with the way that it updates in your graphics window itself. So while you're busy working around it, if you move a light, you can then see, especially as to what effects it's going to have on it. So that is actually very helpful in that, and that was updated in 2020.1. The other section of the light that I mentioned there was the IES profiles and ray files. So basically, with it, it allows us for more advanced complex lighting scenes and sources. So one of the things we've got, as I said previously, was in our photometric or spectral information of our complex light sources. So basically, as I said before, this allows us to do more complex lighting. The IES profiles, and that it allows us to take our profiles and then combine it and use it with our other normal ray tracing modes. Just a quick brief one in the lights.
In VRed 2021 we have reworked our light editor. It is now decoupled and has a full object-based Python API. More information can be found in the Python v2 documentation. Additionally, the light editor has now an improved search field with a filter for the different light types. Also, editing values on multi-selection is now possible. So you can, for example, select multiple lights and edit the color or the intensity for all selected lights in one go. On the ghost lines, we can now zoom and pan for better adjusting lens flare effects that are very close together. These improvements will make light setup more efficient. Thanks for watching the video.
So what this basically means for us then is that it just is enhance the way that we use lights, making our lives faster, easier, and better. Next section that I just wanted to show you was about our human-machine interface. But before that, let's take a look actually at some of the VRed itself. So in here I've got my VRed scene, and as you can see, it's actually a vehicle. Now you can already see that it is actually quite a nice looking scene already. It's got very little actually to it that I need to do straight off the bat. Even when you import it directly, generally a lot of the stuff will import very cleanly if you're using an Autodesk product. You may notice that it's got quite definite lines, this ragged edge that you can see formed over there. This is due to that we don't have any anti-aliasing at the moment. Pardon my language, I do apologize. I seem to have a frog in my throat. Or my tongue. Anti-aliasing, this little guy over here. And once we put that on, you'll notice that it actually starts cleaning up the model like almost instantly. If I zoom out or zoom in, you'll notice all of a sudden the lines start cleaning up. I'm just going to click that off again. And as I move, you can see that it goes ragged. Then when we do ray tracing with it enabled, you can then see the ray tracing part. You're probably wondering, why did I wait until now to show you this? Well, that's because this is where my human machine interface comes in. So for now, I'm just going to go and open up my original menu for my scene plates. It's going to ask me, do I want to destroy the scene? And the scene's gone. So this is basically, in a nutshell, I just want to quickly explain this, and then when I'm showing you about the VR system, you'll see them actually using one of these in real time. But in a way, we can use our menu to do things like this. So we can say, okay, animate like the box, the cylinder, the cone, or the circle. Change its colors, or even where we want the menu to be. That's pretty handy. Jumping back to our vehicle again though. You'll see that it gives us also many options, and one of the options that you'll see just now is when they get into one of the vehicles, they can actually use the menu on the inside screen. In this case, you could maybe even use it to do the cell phone inside there. So inside here, just a quick look inside the actual program itself before I carry on with the rest of the presentation, is let's take a look over here. This is the graph. The graph then tells us exactly what is inside the system or our scene, and all these little subnodes. So root of the file, GNS, which would be our locations, and then the environmental transform, interior, exterior, doors, tires, etc. And then their subgroups below that. But the main thing I just wanted to quickly show you here was if we go to things like, let's say the materials, a materials panel pops up, and it's really cool because we can then start playing around with this, which I'll get to in a bit. For now though, what I wanted to quickly just show you was just about the menu and where we could possibly use it in there. Next thing in here is we can also do things like pre-rendering our shadows into our geometry, which then increases the quality and reducing the time spent on it. So if I was to just quickly show you this, so if we take a look, this is ambient occlusion with the baked shadows on, and as you can see the quality looks quite different. Baked shadows and occlusion. And this is an internal shot with it on, and then with the baked shadows. So as you can see, it was just a quick flip over and no real passage of time passing between it, because these shadows get actually baked in. Now there's also quite a few different programs that can do it. It's just VRed does it and makes it quick and easy to do. We've already spoken about this now, but this is a very important thing to note, especially when it comes to VRed, is that with the subsurface scattering, it allows us to do things like, for instance, with these translucent surfaces that normally would be very difficult to use. Now, by default, we use it. There's two different calculations that is done, or two different methods, sorry, that is done for doing this actually. But It offers a lot of flexibility. And so some of the things that you can actually change and play around with inside it is the color, the roughness, attenuation, which is the distance that the light travels through the surface, asymmetry, which is the directional characteristics of the light, so how it is coming into the material, the medium, so how the thing is going to react. And when we're talking about it just now, you'll notice what I mean about the refractions. And then the index of the refraction, so how basically much is it going to bend through the material depending on the density of the material. The one thing I did want to just bring to your attention over here is a lot of people don't realize about the subsurface scattering and what it can actually do. But if you take a look at a rendering of a person's face, or even take a look at how the light is going through these thinner surfaces more than it's going through the thicker surfaces, and that is basically what is the subsurface scattering and what it's actually driving and what it's doing. So it helps put that extra little bit into that render to bring it closer and closer to real photorealism. Cool. One of the next things I'm going to speak about is lens flare, and I'll let this video demonstrate it because it's actually quite a cool thing. This was introduced in 2019 where they allowed you to put lens flares directly in it, so bringing it closer to almost real world photography.
In VRed 2019 we can now apply lens flares to lights. So a light can now cause lens flare, as can be seen in the viewport. The cool thing about this is that these lens flares are working in both ray tracing and OpenGL. To create a lens flare effect on a light, open the light editor and create a point or a spotlight. In the image processing tab, you can now see an option for a lens flare, where you can enable and set up this new feature. In the lens flare presets is a collection of ready-made lens flares, which will cover headlamps, tail lamps, sun and street lamps. Additionally, you can create your custom lens flares by right-clicking into any empty area. You can then create a glow, starburst, streak, ring or ghost line and add the feature to your light. You can also start with one of your presets, go back into custom and edit the existing lens flare to your needs. Now you can either edit single elements by selecting them and changing the parameters below, or add additional elements, copy them or delete them if not needed. In case you want to use your custom lens flare for other lights, simply do a right click, edit, copy lens flare, followed by right click, edit, paste lens flare onto the target light. If you want to use the lens flare in other scenes, just add the light from the scene graph to the asset manager and reuse it from there. Additionally, we give you the ability to render the lens flares as a separate pass for more freedom in the compositing process. Thanks for watching the video.
Yeah, so as you can see with that, you do have a lot of options that you can do with it. My personal favorite when it comes to the lens flares is actually the ability to copy and paste the data from the one to the other. It just really helps with when you're trying to manage a lot of information or copy a lot across. Okay, the next section, which is also new, or newish should I say, is the new fog effect in VRed.
It is now possible to add a fog effect to your scene with VRed 2019. This atmospheric effect helps provide a more realistic look to a scene. The fog effect can be found in the camera editor under the image processing tab. We have two different types of fog. The first one is distance fog. By clicking on this checkbox, it is enabled. All fog parameters will be active and you can set the fog color, the fall off of the fog, the density, the distance which defines when the fog is starting, and the noise parameters like noise size, noise offset, which can be animated as well. The second fog effect is hide fog, which can be enabled by clicking the checkbox. As with the previous effect, You're also able to set the fog color, the fall-off type from realistic to linear, the density of the fog, the min-max values which define when the fog starts and where it ends. With the noise parameters, you can also add additional noise to it, and the blend range option defines the transition strength between fog and no fog. Additionally, fog can be rendered as a separate render pass within the render settings, which will give you more freedom in composing the image or animation. Thanks for watching the video.
Ah, thank you. So that was about the fog, and it's quite cool what you can actually do and accomplish with it. So one of the main things, and especially with us when we're doing renders, what people are really after is realistic materials. How realistic is our materials? I mean, what's the point in trying to do a photorealistic render? I mean, if your materials don't look real. And that's one of the, I think, one of also the tricky things we have to do in that. So with some of the materials that we've got in here, it's amazing to see as to how far you can actually push these and go. And I take a look at renders like what I've got on the screen here, and it just goes to show as to how fast and easy VRed actually makes this. And yeah, so carrying on with the materials, one of the reasons one of the ways that they actually do this is with the measured materials. So with the measured materials, it gives us very accurate ways of actually creating these renders, because it actually ensures a photorealistic render by using the actual information, such as like how is the reflection going to come through, how glossy is the surface, what is it going to do actually with the material, what the angle it's attacking it at. It takes this all into account, and once this is baked, you end up with the, or not just baked, sorry, I'm part of my wrong word there. It is more to do with how everything comes together, and it meshes it all together, and it creates this amazing end result. And it's very difficult to get more accurate than that, especially considering the amount of effort that you put into it and what you're getting out. Yep. So if you want to just take a look at this video.
Open the Create Convert tab in the Material Editor mapping.
Sorry, I'm just
Please view the
jump
in the category
where I was talking
chain
about.
1.
So as you can see over here, where the gentleman was doing the demonstration, you can actually see it's been applied over there. And when they start applying it, you can actually see in the render. Now, just bear in mind that this is quite a funky angle that he's sitting at, and this is also one of the older versions, but it gets actually very decent very fast. And that is in the measured materials. One of the other reasons what actually makes most of these programs, not just VRed, but you'll find this in a lot of the other ones, but most of us, we use these physical camera settings, which would be as how you would normally pick up a camera, like a DSLR or even a quick point and shoot type camera. And this allows us to get real world type feel out of our renders. And for those of you that are veterans in the field, probably know this far better than myself as well, in some cases, is that, you know, you're wanting to, the best way to try and make something look real is by trying to simulate that reality as best as possible, as strange as that does sound, I know. So this is what our physical camera settings are about here. So we can set things like our focal length, the sensor that it's got on board, like how is the thing moving around, our viewing angles, and then even things like maybe if you're wanting to go into stuff like our clipping, etc. But that goes off beyond our physical camera settings. But it does enable these. I mean, even our depth of field and our motion blur if we're moving the camera around fast. One of the other things that I thought was really cool, and I saw this really cool VRed professional case that I've got here, is a way of using displacement mapping. Now, normally people use displacement mapping for things like textures, etc., and it's very cool, but I found this and I thought it was a really cool idea as to what they've used here. So what they've done is they've gone to basically NASA, grabbed a file, sorry about that. So this is the point that I just wanted to get at, is if you're looking over here, what they've done is they've pulled in a map image off NASA, and then they've actually combined it together, and they've worked out and they've rendered the actual displacement map using VRed, which to me is an amazing thing, because now you can actually get these amazing features, especially in things like this. So it's just a interesting example as to how some people have actually used the technology, and that is using displacement mapping. Now, this I think is pretty interesting, and glass is one of my favorite topics when it comes to rendering in that, because it's an interesting thing as to how it interacts with itself and other objects around it. Because especially if you've done things like trying to have two surfaces together when you're trying to render a transparency, you'll notice that you get weird interference that occurs, and it never comes out exactly right. But the way that VRed's been handling it is quite interesting. And especially when you're working with things like layered glass materials, because with layered materials, they're pretty special in the way they handle things, but glass is even more so, because when you've got two pieces of glass together, what it will do is it will actually go and it calculates the refraction index of both materials, and then it applies it. If you've got more than one material, 3, 4, 5 materials, all it does is it works out the index of the first one and the last one, and the rest of it is basically added to the input as the color, basically how it's going to come out, and one or two other little things. So it's amazing to see actually how the technology handles this type of problem. And as you can see here, this is a render that I picked off the forums that I thought was beautiful in the way that it demonstrates this. As you can see, the light is coming through. The sphere that is embedded in the glass object with the wavy lines is beautifully rendered through, and the refraction index coming off there, it's just, to me, I love this. It just looks amazing. Okay, next, something that a lot of people are getting into and loving at the moment is the presentation in VR. Now, a lot of people see VR as in being like, oh, it's an expensive toy and, you know, a lot of other things. But in my opinion, that's exactly what they were saying about things like computers and a lot of other things back in the day. And, you know, looking at current technology and the way it's going, and currently we are sitting in this whole working at home experience, it just goes to show how much we can actually do from our home, from a virtual environment. We already are working virtually in CAD, over the phones, Skype, etc. But now we've got the ability to work inside our CAD models themselves. And this is what's really changing it in my aspect, is the ability, on my view, sorry, is the ability to get inside the CAD model and work with it. So, without further ado, I'm going to give you this nice little one. Oh, I forgot an N on that presentation.
Virtual reality is no longer the future. It is very much the now. It has been made accessible to everyone by major improvements in this relatively old technology. graphic cards, head-mounted displays, and moreover, software has enabled us to achieve truly stunning results while being affordable to the masses. The use cases for VR are not restricted to gaming. They cover new areas which were previously not considered as viable. Imagine the value of using multiple head-mounted displays for an interactive design review, unlimited by physical boundaries, exploring a detailed engineering model for initial quality checks, inspiring a potential customer with a mind-blowing emotional point-of-sale setup where they can configure and interact with their dream car.
Autodesk capabilities offer the possibility of visualizing all types of 3D data out of the box with the minimum of preparation. Breaking down the barrier between 2D and the 3D world is achieved by offering unparalleled visual fidelity, intuitive interaction, and a high frame rate. This allows the viewer to dive into an amazing 3D virtual world with completely unhindered movement, using real-world tools to interact with the model. VRed, or VRed, Autodesk's unique real-time rendering tool, supports all of these requirements in a way that has been never seen before previously. Consider working with a flexible toolbox, where the only limitation to what you equip it with is your imagination. In this toolbox, we have a flashlight, for example, for lighting up areas which could potentially be problematic in terms of perceived quality, a sectioning or a comparison slicer which can cut the car in two without causing any lasting damage. Even the clay process can be explored without a large invest in time and materials.
Of course, spending time in this amazing virtual world gives us huge benefits over the real world. 3D data is part of every design process nowadays and can be visualized with fantastic quality, quickly and with minimal costs. Additionally, we can collaborate with others in the same virtual world, which brings a new dimension to a design review. Just imagine our colleagues in San Francisco, Los Angeles, or Toronto can join us in Munich, and we can interact with each other in real time, although we are separated by 10,000 kilometers. We can see where our colleagues are positioned in the 3D world, and even see what they're looking at and how they interact with the 3D scene.
All of this gives us a phenomenally realistic way of looking at our 3D design model, enabling us to reach design decisions at the earliest stage possible, before we even consider committing to the physical prototype stage. A process like this was unthinkable even 2 years ago, and this incredible technology is developing and improving at light speed. Using Autodesk's VRed and high-quality head-mounted devices like HTC's Vive, we see today's real-world processes as accessible, cost-effective, and most of all, virtual.
So as you can see there, it's amazing to see what people are actually doing with this technology now. Just a quick look as to more on the hands-on when it actually comes into this.
In VRed 2019, we are introducing a new VR hands interaction method. It is now possible to see fully rigged and posable hands in VR, which have preset gestures like you can see here in the viewport. This makes the VR experience more realistic and natural, as you can get better visual and haptic feedback in VR. The VR hands and their gestures can be controlled by the HTC Vive and Oculus controllers.
I'm just pausing it there because I just wanted to explain. Remember about the menu interface that I mentioned earlier, and I said it was going to be in the VR. So this is kind of part and parcel of the course of what you could actually do with it, is have these interactive menus that you can actually work with also in the VR side.
As you can see, the VR hands are working with HTML5 content as well. You are now able to explore.
That HTML content he was talking about was part of the core feature that we were explaining right in the beginning. That was actually streaming the information there.
Explore HMI designs directly in VR using the VR hands, which gives you a more natural look and feel. Thanks for watching the video.
Cool. So that was also very hands-on. Now I'm just going to quickly skip ahead on this one because I just wanted to show you part of the animation side, and this also kind of starts working around the 3D
clones easily.
And as you can see, NURBS is just driving the wheels, then you can see how it's going to function and perform. And not only that, but you can also have your different variants. Now, before I get onto this rendering side, I'm just going to quickly switch back to my model that I had open here in the back. And there's a reason why I wanted to go through some of this stuff first, is because if you take a look, now we've got our 3D model over here. And now let's say for an instance, I love this car, it looks so amazing, but you know what, I'd actually prefer it maybe in black. I know it's not a Ford, but some things are definitely better in black. Or maybe we want blue fire. Ooh, that looks gorgeous. Yes. Or maybe we want to go and we can change to a different environment. So maybe an empty garage. As you can see, we've got an option to select these different scenes and variants directly inside our CAD model. It makes our life so much faster and easier. And maybe even throw a little bit of love Autodesk way. So, going back to our PowerPoint, rendering. So, in the end, what can we expect apart from some delicious renders? So, render passes and rendered layers for additional post-processing and basically exporting our renders to be adapted for further adaptation, in other software, such as if you're taking it to Photoshop or Illustrator, maybe in the Adobe side, or otherwise you could even be maybe taking it to something as exotic as GIMP or something. What we can also do is we can have better results with fewer cycles, because what we've got that's built in is the noise reduction that allows us to reduce our cycles. So every time it cycles, it goes through it. This is more on the NVIDIA side though, so you may need a card that is suited towards that. Multiple rendering modes. So this will help to give you basically a leveled display situated to exactly what you require at that speed and time. Cluster Manager, which allows us to manage our system or manage our job across multiple systems, help schedule the systems and make sure things arrive on time. And that is the same basically with our sequencer, which does very much a similar thing, but just on the sequencing side. TrueNURBS, because it helps us build the topology and manage it, and then also we can use the local data, or otherwise we can rebuild the data. And then and last but not least is spectral rendering, which achieves our color correctness, and it helps capture that true realistic look of something based on the wavelength of light. Cool guys, so I hope that gave you a brief overview of some of the things you can expect in VRed. If you've got any questions and answers, please don't hesitate to contact me. Thank you very much. Hope you've got a great day. Trust from Micrographics. Have a good one. Cheers, bye.